Okay, so hello friends, welcome to our online live session for 8051 tutorial series. So in this today's live session, as you know, we are going to talk about interfacing of 16 cross 2 LCD with 8051 microcontroller. So, if further, we also provide online training, helping technical assignments. We do freelance and industrial projects based on embedded system, data science, Python, machine learning, Matlab, LabVIEW, etc. So, if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So let's continue with the today's live session of interfacing this 8051 microcontroller or the LCD with 8051 microcontroller. Okay, so uh, as we follows our procedure, first of all we will be talking about like what are the very basic structure of the LCD, or what are the different parts of the LCD. Okay, so you can see here is our LCD. Let's this is our today's session, LCD interface. Okay, so a section cross to LCD looks something like this as it is shown in this figure, right? And it is generally used to display alphanumerical characters and lots of messages in it. So there are several pins available to it. So these are the power pins, and this is the command pins. Command pins means through which we set the mode of the LCD, whether it will act in command mode or the data mode. So when I said in the command mode, then we send the commands to it, whether it is used to clear the screen, increment the cursor, whatever it is. And when we say in data mode, in which when we send the data, whatever data we send, that data is displayed over the screen. Okay, so that is decided by these 3 pins, and these 8 pins are the data pins. So whatever either command or data which we want to transfer or to display to this LCD, that has to provide it from. And then these are the 2 pins through which are used to backlight. Okay, so it is plus and it is minus. So if we apply it, a backlight will turn on. So different power supply and other values which has to be connected to these pins are provided here. You can see VSS, it can be connected to ground, then power supply is to apply to second pin, and then third pin is used to contrast. So if you can put a potentiometer and from that potentiometer you can change the contrast, but if you want full contrast, we can also connect it to the ground. Now this is the important pin, RS. So RS decide if we apply a 0 here, that indicates we will be accessing the command register of the LCD, right? So in this case, whatever data we are providing here, that will act as a command. And when RS is equals to 1, that indicates it is a command, it is a data register. So that means at when RS is put 1, and whatever value we are providing here, that will act as a data, and that data will display over here, right? And similarly this RW read or write, so we will set it to write mode only always. So we can also connect it to the ground. And then there is a enable pin. So enable pin is stable. A high to low pulse is being transferred to this enable pin. As soon as this high to low pulse is transferred, so whatever data values are available at these pins, those pins, though that data got latched inside the LCD. So you can think of it in a way like as soon as you put a high to low pulse there, whatever data is available at these data pins, that goes inside to the LCD. And as I said, all these are the data pins. So we will be interfacing this LCD in a 8-bit mode. So it can also act in a 4-bit mode as well. But right now we will be operating in a 8-bit. Okay, so Remember, all the data goes in a form of a hex values, so it should be remembered. Now these are the different commands which can be used to operate this LCD in different modes. For example, clear screen, and to initialize the LCD in different mode, 8-bit 2 line. Similarly, we have 4-bit 2 line by sending this kind of data to it. Then display on, display on, cursor off, all the things are available here, and that can be sent to this command, and that can be used to display. So now we will be seeing how we are going to display our LCD with, or how we are going to connect our LCD with 8051 microcontroller. Okay, so we have here 8051, and here we have our LCD. So in the meantime, if any one of you have doubt, then you can let us know by commenting, by typing your question in a chat session. Okay. So continue with that. So there are two pins which will be connected. So there is a RS and enable. So we will connect pin 1.0 as RS and P1.1 to enable, and then there will be data pins. So P2.0 to 2.7, port 2 pin 0, port 2 pin 7. These will be connected to the data pins. Okay, of this LCD. So now we will be writing a program to to interfacing of it. So prior to that, today we will create a small first of all we will create a small the diagram. We'll create a diagram of it on Proteus, and then we will move forward with writing the program. Okay, so let's jump to the Proteus then. So within Proteus, okay, let's save this one of our project. We'll create a new project, and we'll create a new project LCD underscore 8051, and we'll save it to our own location. Okay, live. So here is our 7 LCD interfacing. So our folder is selected, and project name is LCD05, and next, finish. Okay, so we will select our microcontroller 89C51. Okay, there it is. So as we discussed, like, we don't have to provide power supply or something like that here. Okay, so it seems like P1.0 here, 2.0s are available here. Okay, so now let's connect our LCD. 16x2 alphanumeric LCD is available here. No, here. Okay, so first of all we'll connect all these. We will connect one by one. So first of all, these data pins we are connecting. As we said, port 2 is connected to the data pins. Okay, and then P1, this will go to RS, and this will go to enable. Right now we need some ground. So there are a lot of are connected to the ground. First pin is also connected to ground, third pin, and this RW pin will also be connected to the ground. And then we'll have our power supply. Yeah. Okay. So let's save it. We'll double click on it. Okay, it will be operating at 12 megahertz program file which we have not created yet. We will now jump to creating this program file. So by default we don't have to put Excel here right now just for the simulation. If you want it to make more realistic, then you can create the simulation this crystal oscillator and reset circuit as well. Okay, now we'll go to the Keil, and here in a Keil we'll create a new microvision project in the same folder. Okay, so we will create a LCD 8051 and save. So here we'll select our microcontroller 89S52. So you may be wondering, 89S52 we are writing the code and there we have selected 8965. So both are same, code will work on both of them. Okay, and yes, and here it is. Now we will add a new source file to it, add a new item. Here we'll add a main file by the name of main.c. Okay, and then we'll go here, and here we'll select our frequency 12 and output. We'll generate our source file and okay. First thing we'll do, we will include our header file reg52.h, and then we'll create void main. Right, now we will need our delay function, so we'll obviously we'll go through the same. We'll use the same code which we have used in our earlier videos. So let's see. Okay, here main, and here's the delay. Yeah, this provide delay in ms 1 millisecond of delay, right? So we will use here as well. Here is the delay. Okay, that is one thing. Yep, fine. Now we will write different functions. So first thing, as we know, in order to, first of all we need to send command, so we'll write a function to send any command to it. So in order to send command, what we have to do, we'll send the command, but out of these three command, these lot of commands which are available here, we'll send these commands here, and then we'll select whether to select rs or not. Okay, and then we'll send the pin to e. So let's make a specify. Let's first specify p1.0 is rs and p1.1 is e. Okay, so we will go to here. Okay, we'll now we will change s bit rs equals to p1.0 and s bit e equals to p1 to 1. Yeah, we'll compile it. Let's see whether, okay, there is no error. Okay, now we'll create our another function void. We'll name it lcd underscore cmd, so it makes a cm command, and we'll type unsigned char of command. Okay, so first of all what we'll do, and let's define lcd as well. Okay, let's see whether it will work or not. Hash define lcd as p2. Okay, let's compile it. Zero error. Yep, target is created. Okay, so we'll type lcd equals to command. First of all we have sent the command to these pins. Now we'll select the status of rs. So rs has to 1, so rx equals to 0, and then enable, because high to low pulse, as I said, right? So first of all we make to it high, and then we will provide a small delay of 1 millisecond, and then we'll make 0. Okay, so this is the command, and similarly we have to send data for we have to write a function for data. So lcd underscore data, so unsigned char data. Again, first of all, lcd equals to data, and then we have to choose rs1 and then enable pin as 1, and then we provide some delay, and then we'll make 0. So by making enable, by sending 1 and 0 to this enable pin, it is making a high to low pulse transition there. Okay, both the functions are ready. Now test it in the main, right? So first of all, let's create another function as well, lcd initialize, lcd init. Okay, so in order to lcd init, we have to send some kind of data. First of all, we will initialize by sending 0x38, then we'll clear the display, and then we'll put this one, display on. Okay, either you can put 0c as well, display on cursor off. So let's write it. So we'll call our lcd data, we'll call it as yeah, 0x01, 0x38. Okay, was lcd command 0x38. It will initialize the lcd in 16x2 mode, then lcd underscore command 0x01, it will clear the lcd, then lcd underscore command 0x08, it will enable turn on the display, and yes, it will turn on. Now there's one more thing in the lcd. When I'm saying 16x2, so it means there are 16 column and the 2 rows. See, so these are the 2 rows, and the address of this row starts from 0x80, and the address from of this is 0xc0, right? And then there are 16 columns there. So the address is like its address is 80, it is 81, it is 82, and so on. It goes up to 8f. Similarly, the addresses of the other one. Okay, cancel draw. Yeah. Okay, it is not visible here. Let's take. So address of the second row is C0, C1, C2, C3, and up to the last address is CF. So if from here, if we want to display any character at this location, so we have to pass the command 0x8 to the LCD. Okay. Okay. So now we have initialized the LCD. So let's go to within this LCD as well. We will send the command to turn the display at 0x80 location. Okay. Now we come to main, and here first thing will initialize the LCD, and then we will display some character here. So LCD underscore data, and let's say S is print, and then because we want. So one of the benefit of the LCD is whatever data you send it to it, it will remain there. Okay, so you don't have to send it again and again. The controller within which is available within the LCD, that will hold the data. Okay, let's compile it and see if there is an error. Yes, there is an error here. LCD equals to data. Okay, let's try to change it. Okay, now there's zero error. So I think data is by default some keyword, so that is why it was showing an error. So now let's see whether it is displaying S there or not. We'll add our hex file. Okay, and then okay. Now let's see it. Oops, nothing is displayed there. Okay, This is strange. Let's run it again. It seems like these things is not connected here. Now okay, now let's see again the coding. We were providing a delay. Okay, here send the command port 2. It is also same. Okay, and yes. These two pins are behaving strangely because we have connected to ground. Okay, these are not connected at all. Okay, it is not connected. Delete wire, delete wire. So in order to do simulation, you must be very careful. So first of all, we'll connect this, and then we'll take a ground here, and then we'll connect it. Okay, yeah, now it is fine. That was problem because ground was not properly connected. So let's try to avoid this extra delay which we have created, because sometimes if we are not providing the enough delay, LCD don't work at all. Okay, so let's, okay, as I think this is the case. Yeah, so we have to provide some amount of delay after 0. So I think this delay will be better we provide here only. Okay, then we don't have to provide again. Okay, so let's run it. Yeah, now it is fine. So this is how we can display a single character. Now let's say we want to display a complete string of it. Okay, so we have to these are the basic command like LCD data and LCD count. This is a very basic function, and these functions will be used whether we want to display of n number of strings on it. Okay, so here we will create another general function to display a string. So we'll type void LCD underscore string, and then unsigned char will take a pointer type str. Okay, so we'll take the pointer of the string, and then while value at the string is not equals to null character. Remember, strings are always end with the null character in C, so we can use that. And then we'll typing the sending the command to the LCD. So it right now it is in auto increment, so we don't have to increment after everything. So we'll send like LCD underscore data and the value at the string, and then we will increment the pointer by 1. Okay, so now I think it's fine. Now let's say instead of this LCD data, right, okay, let's send some command LCD underscore CMD. We will display the string at different locations. So 0x C0, it will display character string in the second line, and then LCD underscore string will send, okay, we'll pass string directly hello and JCVR will passing this string. Let's see. Okay, command error LCD CMD. Okay, it is in capital. Let's compile it. Zero error. Yeah. Now let's run it again in the simulation. Yeah, you see, hello. So this cursor is looking odd here. So let's see what command which we can use. Okay, display on, cursor off. So we'll send, instead of E, we'll send 0x0c there. So we'll go to our code in LCD init. We'll send 0x0c. Here it is. And then yeah, okay. Let's run the program again. Yeah, now there is no cursor, so it is a pure and good one string. So you can display string, you can display simple character, whatever you want. Let's try to with something else. So it is like if we want to create a moving display, right? So there is a thing like there is a command, shift entire display left or shift entire display right. Okay, so let's say we'll create entire display right. So we have to keep sending this 0x01c command to it continuously, so it will be like moving LCD. Okay, so let's say within this while loop we'll send LCD underscore CMD 0x, and let's see what we will get 0x1c. Okay, it is moving very fast because we have not provided delay there. So let's provide delay at an interval of 1 second. It should rotate. Okay, so its left is like this. Okay, so this entire display is rotating. And now you will see some other after, because they are total 15 or 16 character. So when all this rotation is done, it will further rotate. So after some time, you will start seeing original command as well. So it is interesting, and you can create with this information. You can create different kind of small project based on LCD. You can interface switches there because we have discussed all those things in our earlier classes, and you can also interface different other components with 8051, and you can create really very cool application or based on 8051 micro. So I hope you understand it, and if you have any doubt or any query, then you can let us know by commenting below this video or typing in the chat session, right? And further, we also provide online training, help in technical assignments. We also do industrial and freelance project based on embedded system, data science, Python, machine learning, etc. So if you have any such requirement, you can let us know by commenting below this video. And yeah,